doesn't work. It doesn't work. Yeah. So 7.3 is going to be solving exponential equations. Well, it does, but it doesn't last long enough. So an exponential equation is an equation in which the variable occurs as an exponent. So the main idea you need to know here for the properties is that once you get the two bases to be the same, for example, if b to the x is equal to b to the y, then it must be true that x equals y. So if the bases are the same, you can essentially set the exponents equal to each other and solve for the missing variable. And then we're going to talk something about compound interest, interest paid on the principal of an investment of any previously earned interest. So let's go ahead and practice some of these problems together. So first thing you have to do with any of these problems is you have to get each variable written in the same format as the other. So what's another way that we could write 9? Something to the power of something. 3 to the power of 2, right? So I can replace 9 with 3 to the power of 2. And how can I rewrite 27 so it's 3 to the power of something?
9 to the power of 3, or 3 to the power of 3.
3 to the power of 3, good. So we get to this point, and now what you're going to notice is the bases are the same, right? So since the bases are the same, that says we can set the exponents equal to each other, but we have to first fully simplify the exponents. So this is power to power rule right here. And does anyone remember what operation we do with power to power rule? Multiplication. So this is really 3 to the 6x is equal to 3 to the third. So now we can go about actually setting these exponents equal to each other. So once they have the same base, you just simply set the exponents equal to each other. Okay? Is everyone good with that?
Yeah, how'd you get 6?
Oh, I'm sorry. I don't know why I was like looking at, it's 4, isn't it? Sorry about that. Yeah.
Where's the whole bunch?
It's around somewhere. Probably over there.
Oh yeah.
Thanks. So this is 4x. So then we're going to divide both sides by 4. And we get x equals 3 over 4. You can always plug it back into the original too to verify that it's correct. So do we have any questions on letter A?
Oh, you did.
Yeah. What'd you say?
That's all you did.
Yeah, that's it. That's it. Alright, so letter B. As you can see, we have a base of 3 and 27. We want to rewrite one or both of the bases so that they match. So I can rewrite 27 as what?
3 cubed.
Good, 3 cubed or 3 to the third. And then we're going to multiply these together. So you set the exponents equal to each other. Okay? So this over here is going to become 6x. That's where I was getting the 6 from, I think. The next question. So I subtract x on both sides. That gives me 2 equals 5x, which gives me x equals 2/5. And you're going to leave your answers as a fraction, typically. So any questions about that procedure? Alright, perfect. So next one. So we have a base of 16 and 4. How can we rewrite 16?
4 squared.
Good. So now that I've written it as 4 squared, I now have the common base. So here's where you have to be careful. In order to multiply 2 times 2y minus 3, I have to use what property? Distributive. So this is really going to be 4y minus 6 equals y plus 1. I'm going to subtract y on both sides. And then I'm going to add over the 6. And then I'm going to divide both sides by 3, which leaves me with y equals 7/3. Sorry. So any questions about that procedure? Alright, we're going to do one more problem together, because this one here is where people don't get it right usually without addressing it. So, not 0.5. What's another way we can write 1/2 so that it's not a fraction anymore? How about I give you a hint? What if I rewrote 1/2 as 1/2 to the first power? And I want to get rid of the fraction.
1 negative 2 negative.
Good. 2 to the negative 1. And then how can I rewrite 8 so that it's something 2 to the power of? Good, to the third. Now remember, now that the bases are the same, we can set the exponents equal, and we're going to use the distributive property. I'm going to start by adding 4x to both sides. And then I'm going to subtract 3 on both sides. And then I'm going to divide by negative 4. And I end up with this, but that can be reduced, right? What can that be reduced to? Good, negative 5/2. So this is a really big topic on PSAT and ACT where they change a base. So this is a good one to practice and learn. So does anyone have any questions about this before we move on to more exponential stuff? Anyone at all?
Wait, I have a question.
Sure.
Why did you divide by 4 instead of 10?
Why do I keep doing that today? Sorry, that's my fault. I divided backwards. It should be negative 2/5. Sorry, guys. Some days my brain just wants to mess up the numbers. I don't know. Math overload. Alright. So the next questions we're going to be looking at are going to deal with exponential functions in this format right here. So this is the most basic form for an exponential function. Now, what can be a little confusing is we've learned yesterday about formulas that use p in them for the principal. That represents an initial value. But in this context, lowercase a always represents the initial value. So what I want you guys to think about is the a represents the starting point. Now, this typically in the form of a graph will represent the y-intercept. Okay, so like if your y-intercept's 4, a is 4. The b represents the growth or decay factor, which is the same thing as either 1 plus r or 1 minus r, depending if it's growth or decay. So that's the standard form for an exponential function. So we want to use the information right now to see if we can come up with our own exponential functions. We're going to be doing a lot of calculator stuff here, so if you're struggling with the calculator, I'll try to help you guys as much as I can, but I'm going to have to come around and help you guys individually at the end. So just make sure you understand the steps up here, and then I can help you guys each individually with that. So it says here, Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 2,300 cells. So step 1 is we want to figure out what we started with. Little a is always going to be what we started with, our y-intercept. So what is our little a in this case? Good, 7,500. Now, they're always going to provide us with a starting amount, and then they're going to provide you with some information, some data point on your graph. So it says that after 4 hours, there are 23,000 cells. So which of those two are correlated, right? But which one is the independent variable? Which one causes the other to happen?
4 hours.
Yeah, time is always the independent variable, typically. So when we go to write a coordinate that represents that relationship, your time is going to be your independent variable. So what that's saying is there's some point on my graph where at 4 hours, we're at 23,000 bacteria cells. That's what that coordinate represents. So we know that coordinates are written in the form x, y, or it could be ty, depending on the type of equation you're using. So basically, we have enough information that we can work backwards to find b now. So what we're going to do is we're going to take this equation and we're going to work backwards to find b. So we're going to plug in for y. We're going to plug in for a. And we're going to plug in for x. So we get to that point of our setup. And now our goal is to find b. So to do that, I'm going to start by dividing both sides by 7,500. And I'm not going to put that in the calculator just yet. I'm going to leave it as is. And then I have to get rid of that fourth power on the b. So what can I do to both sides to get rid of that fourth power? Good, the 1/4 power would get rid of it, right? But if I put one side to the 1/4 power, I have to put the other side also to the 1/4 power. So these powers cancel and I'm left with b equals whatever this calculation comes out to be in the calculator. So I'm going to talk you guys through how I'm going to type this in. So let's go ahead and get started. First thing I'm going to do is I'm going to type in 23,000 divided by 75,000 equals. And you're going to get 3.06 repeating. Okay? Once you have that amount, you're then going to hit that little caret button. It looks like an upside down V all the way to the left in the middle. Okay? You're going to hit that button. And then you're going to do a left parenthesis. And then you're going to type 1 divided by 4. And then you're going to close the parentheses. So you're putting it to the 1/4 power. You're going to then hit enter. And if you did it correctly, you should get 1.32 as b. Okay? So if you're struggling with that, I can come around and help you guys after the lesson. Alright, so we got b. So let's talk a little bit about what b represents. B represents my growth factor. Okay? So that means that the bacteria is growing at a rate of what percent? 32%. Very good. So the question asks us, we didn't answer the question yet. It says write an exponential function. So we want to come up with a general function that represents the growth of this bacteria that we can use to plug other numbers into. So we want to write an equation that has an x and a y blank in it. Okay, so we're just plugging in for a and b. So here's how you write the equation. It's always going to be y equals whatever your initial a was times whatever your b is to the power of x. So this equation now models the growth rate of the bacteria, but now we can use that equation to calculate it at any given time. Okay, so we just worked backwards to find the equation. So they gave us some information which we could use to find the equation. So now the next question says how many bacteria cells can be expected in the sample after 12 hours? So now they're just asking us to take the equation we just came up with and use it. Plug in. So it's going to be y equals 75,000 times 1.32 to the power of 12. So that's y equals, this one you can just type in as is on the calculator and it will do it for you. So 75,000 times 1.2 or 32 to the power of 12. And you should end up with this. Now, you're going to notice that I didn't leave any decimal places on this one because we're talking about bacteria cells and you can't have part of a bacteria cell, okay? That means the other ones just haven't developed yet. So any questions about that? Alright. So the next question we're going to look at, we're just going to practice using 2 points to find the equation for any given exponential function. Okay? And this will come up again on the homework. So, step 1 is to identify the 2 points they gave you. I'm going to write them up here. Kind of hard to see on the graph, so I'm just going to rewrite them. Now, one of those points that they give you is going to be a y-intercept. Does everybody see which of those 2 points is the y-intercept? That's this one right here. The y-intercept is always going to represent... Oh, where's the big one? The big one's right there. The big hole punch?
I'm blind.
No, he wants the big one.
Oh.
So,
I did not see this.
whatever the y-intercept is, that's going to be your little a value. So our a is 80, okay, from the y-intercept. That's our starting point, initial value. The other point is going to represent x and y in the equation. So now you're going to proceed with the problem just like you did before. So it's going to be 180 equals 80 times b to the x, like that. So just like we did before, now we can work backwards to find b. So I'm going to divide both sides by 80. And then I get to this point. And then how can I get rid of the 6?
Put both sides to the 1/6 power.
Good. Put both sides to the 1/6 power. That cancels these out and leaves me with b equals. So one more time, again, I'll explain the process. You're going to do 180 divided by 80 in the calculator. Once you have that, you're going to hit that little upside down V button all the way to the left, middle. You're going to do parenthesis 1 divided by 6, close the parenthesis, and then hit enter. And you should get 1.14. Once you have a and b, which we now have, you can now come up with the equation. So the equation is going to be y equals a times b to the power of x. Do we have any questions about that? All right. So now we're just going to practice some stuff we learned about yesterday, as well as some reiteration of it. So we're going to practice our use of the compound interest formula. You should be familiar with that one from yesterday. But now we're going to look at some problems that have some values that aren't necessarily, we used n equals 1 a lot, so we're going to look at some other ones. So an investment account pays. So if it's paying, this is going to stay as a positive in the formula, right? Because it's paying. Your interest rate, you want to represent as a decimal. Next thing it says is that the annual interest is compounded weekly. What does that mean? Good. You're on the right track. N equals 52, because that's how many weeks there are in a year.
Oh.
Okay? I see where you guys are going with it. So if this amount is invested in this account, so if it's invested in the account, that's the principal, that's the starting amount, right? So they're giving you the principal, and then they're telling you the time passed is 5. So now that we have all that information, we're going to plug into the formula. So A equals P times 1 plus R over N to the power of N times 5. So this is obviously a little bit more calculations that you're going to do in the calculator. So I'm going to talk you guys through those calculations and how I would do them in this calculator. So I'll kind of highlight as I go. So the first thing I'm going to do in my calculator is this step right here. I'm going to do 0.0275 divided by 52. And you should get 0.00 something. And you don't have to write that step in if you don't want. Like, you can just keep going. So after I do this step right here, I'm going to move on and do this step right here, which is where I now add whatever I got there to 1. So I'm going to hit plus 1. Okay. Once I get the plus 1, I know I'm now putting whatever that amount is to the power of 52 times 5. So I hit that little caret button. I do left parenthesis, 52 times 5, and then close my parenthesis. And I hit enter. And now I get some value. And then whatever I got for that value, I'm then going to multiply it by 5,500. And when you do all of that, if you do it correctly, you should end up with this. Alright, so what we're gonna do is, at the end, you guys are gonna come back to do B. We're gonna do some try your owns. So we're gonna skip B and come back to it, similar to the last one. Alright. So the next one. This one is using the compounded continuously formula. So, the only time you use this formula is if the phrase compounded continuously is used in the wording of the question. Otherwise, you're not going to use that formula. So, it says, suppose you invested $8,000. So if you're investing that much, that's how much you're starting with your principal. The rate and then time. So in this one, you're only needing 3 values. So we're solving for A in this one. So we get P times E to the power of R times T. So in your calculator, if you remember from yesterday how to get E, if you forgot, if you see that button that says second all the way to the left, you're going to hit second, and then you're going to hit the ln button. And it's going to come up and say lowercase e to the power of. That's where you're going to type in 0.0375 times 30, and then you're going to close the parentheses. So make sure that's in those parentheses. You're going to hit enter, and then you're going to take that amount and multiply it by 8,000. And you should get this. Alright, so that's everything new for today. The last thing I want to show you guys real quick. You guys are going to try the B's on your own. But before you get started, let's be careful on B, because if you wanted to have 30,000, does that represent the final amount, the accumulated amount, or the principal?
Final.
Yes, so that's going to be A. So you're actually going to be solving for P in this one. Alright, so you guys go ahead and try the B's on both examples while we come around with homework.
think it is. If you both
What
got
does
it.
that mean?
Oh, we both wrong.
Yeah.
There you go, Ethan.
Yeah.
Alright, am I on each higher after this?
Just in case it's one of
Just set them over there somewhere. Well, that's for today, so I don't want to. What is
This is for
it?
today?
Yeah, that's for today.
I was confused. Oh, I'm confused because I hole punched this, but this is today, right?
times by
I don't think
That
so.
was yesterday.
And what's the title?
Oh, it's because we forgot to change the title on it. It should
I
say 8.
divided 30,000 by the exponent.
It's okay.
You're telling me that I'm wasting my time.
Why? I didn't know you were gonna be wasting that much time on it.
No, because I thought it was this one, and then I'm like hole punching it. I'm like, I used to put a lot more paper.
So this is the answer to letter B for 5. If you want to see it.
See, now that ain't right. I got it.
So what I would do in this case, is I divide both sides by the e, and I do 30,000 in my calculator divided by, and then I do
Oh,
e
no.
to the
Oh,
power.
wait. This the
Oh,
other one.
so you do it by.
Okay, no.
Oh, you did it by calculator.
I was about to say. That was easy.
And then I'll put up the other one in a minute or two.
Yeah.
We thought that was the
It's
other
not
one.
the same.
So that's, this is in case. Divide it without
So if we
doing
don't know,
the
wait,
first.
140.
I mean, it could be, but yeah, so basically just don't divide, do this yet,
See?
divide it first, don't do this yet,
Oh,
divide.
this is the
He's under calculus.
This is the predator. Hey, Miss Russell. What'd you do there?
How did I get it?
Yeah.
So in my calculator, I put in 30,000